Okay, so you are seeing my screen now?
Yes, yes.
Okay, okay, thanks. Okay, welcome for my behalf also for this second webinar talking about Pedanet platform. And this presentation will be mostly about technical things about building Pedanet. I will give a short recap of the history of Pedanet, which I already did at the first seminar, but it's much more in a briefly form this time. So first, a little bit about the background, where I come from. I come from Finnish Institute for Educational Research from University of Jyväskylä, and this is our Ruusupuisto building in Jyväskylä. Here are some facts about our institute. We are mostly famous of those PISA studies, the Finnish part of the PISA studies, because our institute, most of our employees are researchers, and they do a lot of papers about the PISA studies. And we are not so huge institute. We have only around 80 persons and mostly externally funded. And Pedanet is also part of this external funded part of our institute. And what about the Pedanet? Pedanet is a product and service of this Finnish Institute for Educational Research. It's not so common that university builds something like this, building software and offering it to the market and to the schools. But this just has happened this way, that we have stayed at the University of Jyväskylä. And we develop online tools for learning and collaboration. And we also provide training and support services for using our tools. And also our institute's research group does some research on how Pedanet is used. And Pedanet itself is funded totally at the moment by collecting membership fees. So we are not externally funded as such that we have any project money or so. So all money for Pedanet comes from collecting membership fees from our users, which are mainly cities, municipalities, single schools, hobby clubs. We have many kinds of different users. And we have 10 persons directly working for Pedanet at the moment. 5 of those are developers, which I am part of also. And then five other people's doing the support and training and marketing. And we started the project in 1997. It was a local project for schools only in central Finland to find out what kind of network connection schools have and what they could do with them at that time. Then it was funded by European Social Fund and Regional Council of Central Finland. And we already registered the peda.net domain name during that time. And at first, my first job at Pedanet was to build this first server, which provided project web pages, email server, and mailing list. And it was only for the project. There was no development of any kind at this point. But during the 1998, we were never supposed to produce any software as a Pedanet project. That was the task for the telecom partner in our project. But they had their difficulties in getting those projects finalized. And actually, they did not finish at all. So we started to doing some simple prototypes of web software for schools to run. So it was built at that time with a really simple technology, and all the software was pretty simple and not so user-friendly, but it was the beginning. At 99, we developed a little more software and tested different tools for building those simple web tools. And at that time, our software was quite popular in central Finland area. The schools were pretty eager to use our tools, so we started to expand it and write more software. At 2000, we actually had 2 different tools at the same time, using different technologies for different purposes. But at this time, we already had first users from Europe, because Finnish schools were doing much collaboration with European schools through Comenius projects. So our web magazine was used on those European projects. And we also built a local curriculum processor tool. And 2001, even more software, and first time developing something with PHP and using MySQL database. So because we expanded our development efforts, we had to study and test different kind of tools, what we could use them. And all of these tools, they are open source tools. That is the main idea of in almost every development part of Pedanet, that we use open source tools, even though that Pedanet as itself is not shared at the moment, at least, it's not shared as an open source software, but we are using open source tools. And because we had different tools, different versions, and we were doing quite a lot of development in a quite fast pace, we had our first big failure in 2002. We decided to build a portal next generation from the first prototype using 10 brand new tools, PHP, MySQL, and we failed quite miserably because we designed a too difficult system for teachers, mainly because it had too powerful user rights management, and because the teachers and the students didn't have so much experience in working for the net. This tool was too difficult. And also because we did not offer any way of transferring what they had done with our previous portal into this new one. So if they wanted to use this new portal, they should have started from beginning, from the empty pages, and they did not want to do this. So that was the biggest reason why this project failed. And actually, we never published this software for wider use because the testing already showed that this is a fail. So, because our portal was a success, we continued to expand it using Perl at that time as a technical choice. And this proved to be the right choice because now the usage started to grow quite rapidly around Finland, also around central Finland, in all Finland. So this proved to be a good way to continue. And then we also started to upgrading our different tools using modern technologies, already doing almost everything in PHP. And to prove that these systems were quite popular was that all these services were supported until summer 2017. That was when we all finally shut down all these old services built in the Pedanet. But then we started to think, where do we go from here? We had a positive problem that our users were talking about single Pedanet, but actually we had these different tools which were built on different technologies, and there were some problems at this moment. The biggest one was that because all the tools were separate, also the user IDs and passwords into these different tools were separate. So that was a huge problem. Also, we had built all these systems using many kinds of different technologies, different databases, and so on. And actually, we were running all those services on different servers. So each different software had its own server running it. So our infrastructure was pretty, how should I say it, not so professional, a little bit of hacked together using lots of bubblegum and tape. And also we only had 2 full-time developers, which I was the second one and also another developer. And we had different tools to support and run the servers. So it was quite heavy and we had to do something. So at 2011, we decided, or already we had decided that we should do a unified Pedanet framework, and it was released in 2011. And at this new Pedanet framework, which is the basis of what we are developing now and which is in use now, is this one Pedanet framework. And we put all of our development efforts into this single framework. So finally, we had this single Pedanet, which our users already were calling our tools. We took the ideology behind the system, the principal idea around this ideology called personal learning environment. And we also wanted to combine good features and what we had learned from all our previous tools into this one service. And also we decided that there should be a single Pedanet account for all users. So that's much more easier working with passwords and user IDs. And also we decided that we are not going to do a Pedanet app for phones or iPads. We are building a framework, a system which is browser-based environment for all devices. But we had to took one risk, and that was the old data. We already knew that this might be a problem, and actually it was. So because it would have been so hard and so difficult to import all the data from our separate systems into this new system, which had many things totally in different ways. We did not make any upgrade for the old data. And this actually slowed down the transition into this new system. And at very long time, we had many users which were using this one single Pedanet and the old tools side by side until this summer 2017 when the old services were shut down. So this is the historical background of how we started our own development. Here are some usage statistics from nowadays. So it gives some perspective on how big system we are running. These are from Google Analytics this April. So these are mainly from the most hectic point of the Corona lockdown in Finland. So almost all students and teachers were working from home during this April. And we had 66 million page views that month and 8 million different user sessions. 1.7 million different users, and all because Pedanet has much information which is totally freely available for everyone. Most of these users are anonymous, and we have around 2,100 daily active users. And there are some, you can see some shares which browsers were used the most. This is quite common pattern in all websites nowadays. Google Chrome is the biggest, and then Safari the second. And we have quite tight situation in desktop versus mobile. So desktop and mobile users are quite the same number, and tablet users are only 5% of Pedanet users. And at the moment, we have registered user accounts 490,000 registered user accounts, so almost 500,000 user accounts at the moment. And now let's go more deeper into the technological part. So how we are running these systems. And now I am going to provide information about the current system which Pedanet runs and how we are developing our tools. So at the moment, we have our own servers, and all our servers are running at the University of Jyväskylä Data Center. This is quite important for us and to also most of our customers, because they know the exact location where all the user data is located. And that is an important information from security point of view, because in many freely available cloud services, the users really don't know where their data is located. All critical servers are fault tolerant using redundancy. So we have multiple servers for the same function. And this provides security and minimal downtime because of upgrades and maintenance, because we can shut down and upgrade one server at a time, and all the other servers are doing the running of the service at that time. We are using rack installed servers, nowadays provided by Dell, and they are powered line if some technical person is familiar with those. And we have some custom built servers and virtual servers for supporting system, but the main system which runs the user, all the things that the common users see are from those rack installed Dell servers. Before that, we actually built many custom made servers, because at the time that was much more cost efficient, but it had its own problems. If you build your own servers, then you have to provide all the maintenance and all that by yourself. So we decided to use official servers. And as already from the beginning, all the servers in the Pedanet have been running Linux, and nowadays we are running Ubuntu Linux, mostly versions 16.04 and 20.04. We are actually during this summer upgrading all servers to 20.04 version. We have during the years, we have been running Red Hat Linux, CentOS Linux, Debian Linux, but now we have focused all on running Ubuntu Linux. And all our servers have 1 gigabit or 10 gigabit per second connectivity internally and to the internet. Our servers are divided into different sectors on what they are doing. And the first servers on our farm are the load balancers. And we have 2 of those. All the traffic coming to the Pedanet service goes through our load balancers, these 2 load balancers. They are provided using round-robin DNS, which is a technology which gives users all the time two different IP addresses, to the two different IP addresses of those load balancers. And the user's browser selects the first one. And if this first one doesn't work, then it will try the second one. This system divides the traffic into those two servers. But if we shut down one of them, it automatically and totally transparently to the user allows all the traffic go in only using one server. And then when the other server comes back online, then it will already start providing the service. So this using this round-robin DNS and two different load balancers provides quite good fault tolerance and able to upgrade those servers and do maintenance. These load balancers have quite fast processors, Intel Xeon something. They have 16 gigabytes of memory per server, and they are running from SSD drives for operating system. And we also use this SSD drive to keep a small static file cache of files which are often fetched from our server. And as a software running this load balancer, we are using this HA proxy software, which is really good, really powerful and flexible open source load balancer software. Actually, we were using an expensive NetScaler load balancing appliance, a separate dedicated machine doing only load balancing. But actually it was quite expensive and it did not have all the possibilities that now we have with HA proxy. So we are quite happy with HA proxy at the moment. Then the second and quite critical part is this part of servers, our worker servers. We have three different servers at this pool at this time. And our worker servers, they are running all the PHP code. So these servers run actually the system. So at these servers, we have quite fast processors, lots of memory, 32 gigabytes, because the PHP code likes to eat lots of memory. And also these servers are using SSD drive for their own operating system. And also in here, we have a static file cache, which speeds up things quite a bit because all the files would not be needed to fetch from the database or from our storage system. And at these servers, we are running Apache mod PHP for running the PHP code, and also running command line PHP for background services. And also there is a little bit of Java, because we are running Elasticsearch software for doing all the search indexing and searching. So there is also running a small piece of Java code here also. Then where all the data is our database servers. Also these, we have 3 PCs, and these servers run our database and also the Elasticsearch search index. These also have fast processors. I think these database servers have our fastest processors because these are doing quite a lot of work. And these also have 64 gigabytes of memory because running a big database needs much memory. And these database servers have a quite not so common way of organizing the drives, because there is a wide array of SSD drives for operating system and keeping the Elasticsearch index. And then there is a dedicated Intel Optane SSD card for the database, because this is almost the fastest SSD drive available at the market. So we are running our database from this really fast SSD card. And actually, this SSD card was upgraded during the Corona lockdown, because we found out that our normal SSD array, which we were using previously on these servers, was not fast enough. So databases cannot always be fast enough. There is always possibility of, and all the software gets benefits from running a faster database. So this was actually a really needed one upgrade during the Corona year period, but also for the future, this provides good opportunities to grow the database usage even bigger. And at database servers, we are using PostgreSQL at the moment, so not MySQL anymore, as was in the history. So everything nowadays is running from PostgreSQL database server, and also, as I mentioned already earlier, this Elasticsearch for doing all the search and search indexing. Then, because one big part of using Pedanet is storing external files. This is our storage server pool. And again, at the moment, running from 3 servers. And these servers hold up all the uploaded external files on the Pedanet system. They are running also with quite fast processors and also need quite huge amount of memory. So 64 gigabytes of memory. And at the moment, we have 30 terabytes of drive space for running these servers, their operating system, and also the cluster.fs file storage, which actually stores all the external files. And this cluster.fs system is a replicated system. So all these 3 servers have all the files. So at any time, 2 servers can go down and no one notices anything, because all those 3 servers have all the files all the time. So we have replicated everything for security and for fault tolerance. Then those were the main servers running the system, all the parts which are running the actual Pedanet system. But now I will also tell you a little bit about our support servers. And one very important part of those is a backup server. This is only one server which we are running, which backs up all files and database from our system, and also stores all the logs we are keeping for different purposes. And also all the files on this backup server are also backed up remotely using encryption into the Finnish backup servers. So that is the second layer of backup. If something happens in Jyväskylä and this backup server is not available, we have backups remotely in totally different location. And this is not so fast machine, because most it is doing is only copying files, and it does not have so much memory, and it only has SSD drive for running its operating system. But it has 48 terabytes of disk using old school regular spinning drives for backups. And we are using spinning drives for backup because at the moment it's cheaper to build these big systems, big storage spaces using regular spinning drives. And actually, I forgot to mention with these storage servers that these storage servers are also using regular spinning drives because SSD is quite expensive for this usage. But the prices are going down, so in a couple of years, I think we are running everything from SSD drives. And for taking those backups, the software side of backing up, we are using rsync and Restic software for taking all the backups. And these have been quite good tools for backing up huge amounts of data. Backing up huge amounts of data is quite difficult task, and doing it good, it needs much of learning and refining on different systems, how most efficiently back up huge amounts of data. Then we have a testing server where we only run all our new code and test all the updates before actually updating the production servers. And this is also quite mediocre system running only with 16 gigabytes of memory. But these we like to run from SSD drives so that the speed of this test server is somewhat comparable to our production servers. And everything running in this testing server is the same software components as are in our production servers. So the testing environment gives a good feedback on how things should run when we finally publish those into production. And then our weakest server is our extras server. And this is only one virtual server, which is this server is only running extra services supporting our system. Here we run our email server. Here we have our Git code repository. And this system works as a DevOps system, which gives us tools for publishing code into testing and production servers. And also one important part is that this collects all the operational statistics from all different servers running this software called Muni. So quite simple virtual server. And some other information about how we run our servers. 99% of maintenance work we done with our servers is mainly done remotely. So we don't actually have to visit our data center so often. Everything is done using encrypted SSH connections. All the fireworks, all the servers have firewalls for added security. And also the HA proxy is doing some basic distributed denial of service attack mitigation, which we have had some cases of. And as I little bit already mentioned, the collection of operational statistics from running the servers is quite important. It gives us important information how well our service is running and where and how we should optimize it. So when you are running a huge server farm or big service, collect all information you can because most of the time, more is better with this kind of statistical information. You don't know what you need before you actually need it. So try to collect as much technical information as possible. And using this Munin statistics collected, we have actually find many bottlenecks and been able to improve our system. And especially during this Corona lockdown, when our usage went through the roof, tuning the system without this information would have been quite not so good, and we would have done many decisions by guessing. Now we had the data on what we should optimize and so on. And also what we have learned is that if you are running a redundant and replicated system, all the time, running 3 servers is always better than running 2 or any odd or even numbered servers. Because if you have 2 servers, for example, for the storage system, as we had at the beginning, we only had two servers running the storage system. There is this possibility called split brain situation, which means that when one of the servers goes down and the servers don't know what the other one is doing, there might be situations when they have different files. And when you have only 2 different or even number of servers, there is no way of knowing which file is the correct one, if, for example, the same file changes. But if you have 3 or more servers and an odd number of servers, there is always this situation that you can ask from different servers. For example, that 2 servers see the same file and the one doesn't see. So the 2 servers seeing the file win at the situation when they are deciding which is the correct one. So building replicated system, always avoid even number of servers. Also, keep change logs from everything. And this means configuration and so on. So use something to collect the information, what changes and when, because that is important information when something goes in a wrong way, that you can go back and look at different little changes and try to figure out what had been done and what had caused the situation. So keeping change logs from pretty much everything is really, really important in running these kind of systems and running them good. And here is a little collection of all the main technologies used in building and running Pedanet at the moment. Of course, there are also small pieces of software besides of these, but these are the main ones which we are running. And all these technologies are part of this, what the users see as a Pedanet service. The main technology is PHP, running version 7.4 at the moment, and also JavaScript for running those front-end stuff on the browser, HTML5 and CSS for how everything looks and works. And because we are not building an application for mobile phones, our system is responsive, so all the users can just use a browser. We are using Apache Web Server, PostgreSQL database, ClusterF, Ubuntu Linux, Elasticsearch, also Etherpad and Node.js, because that is behind one of our collaborative tools. It's an environment which works pretty much like simplified Google Drive, where many people can simultaneously write on common shared text pad. So we are running Etherpad and also this HA proxy, which we actually love because it's so fantastic software. And for our work, security is really important for us. And as I already mentioned, all the user and organizational data is stored only in servers inside Finland. Of course, that is from the Finnish standpoint that it's good that everything is in Finland, but also Finland has a quite good reputation internationally of being a quite good country for storing data. All our connections are encrypted, so that is a good one. We try to be quite good at being GDPR compliant, because that is a huge legislation in the European Union about data security. All our code and our development practices have been audited by external auditor. And also we have used a white hat hacker group for doing a penetration testing. And if I may say something about these two different kind of external ways of verifying that you are building secure code, I would say that this penetration testing and white hat hacker group did so much better work than those external auditors. The official auditing processes, they mostly follow scripted checklist and check, is this system this way and had this been done this way, but they don't actually go deep into the system and try to find out different anomalies which are difficult to find. They are just checking this list. But these white hat hackers, they are good because they are trying to use the systems in such a way as they were not designed to be used, and they find the really important security problems on systems. So this white hat hacker group testing was really good. They did not find anything serious from our system, but they actually found out many little security problems which we had not been focused on our development, and which were quite clever. So if you have possibility to use both, that's good, as we have had. So use external auditors, because at many places only these official auditing processes are important when you are, for example, you have to provide certificates of your security. Only these external auditors can give you that. But if you really want to build a secure system, do also this hacker done penetration testing. And actually at the future, we might quite possibly are also going to provide these what's called bug bounties. So we are publishing information to hackers that if they find security problems from our system and responsibly disclose those security problems to us before publishing them to everyone or even to highest paying customer, then we like to pay a bounty for finding those flaws. That is a quite interesting way of getting those good white hat hackers to be your service security testers. But we have not done that yet, but we are actually thinking about doing it in the future. And then the last part of this presentation of mine focuses on how we actually do the software development part of this system. So first, a little bit about the background. So all our 5 developers at the moment run personal virtual machines using VirtualBox software, which is, we have this development virtual machine which runs all the parts needed to run Pedanet, all Pedanet code. And all our developers can freely use what editor or development environment they want to use. At the moment, all of us are using either Eclipse IDE or PHP or Storm at the moment. And all the ideas, new features, enhancements, and bugs related to Pedanet systems, we register into this track issue tracker. So that is our main tool for keeping the information about software development. And then we use Git as a centralized code repository, version control system. And it also is our DevOps tools to automate the publishing process of getting the code into production. During this, when we are doing development and deciding what we should do next and how, we call this system called t-searchizing. And this is a process which we use on all items on our track issue tracker. And we evaluate all these different items using these SMLXL labels. And we have 4 different aspects of each item. The user effect, how valuable this feature or bug or everything is for the user, how important this is for marketing, how important this is for our development, how it is it good for our system, and also how difficult from development standpoint this feature is. And using this information, we prioritize what we do and at what time and so on. So at different times, we try to find different things. For example, during this summer, we are mainly focusing on doing things which are quite easy to develop. So development difficulty size is S, but the user effect is at least L or even XL. So we are trying to pick up the easy things which are valuable to our users. And for some other times, we are taking focus on items using different things. But this t-searchizing process has been quite good for us, because before this, we had a little bit difficulty of how to decide how important each new feature or different development effort is. And we had a little bit of problem that we were doing too much at the same time because we did not prioritize those things. So this has worked quite well for us. Then when some feature enters into this development phase, what happens then is that one of the developers is always given main responsibility of each item. So each developer takes these items to do, and they are something like a project manager for getting that thing done. But other developers can also work with the same feature, of course. But the one is the main responsible one. And then there is always one of the non-developers, our marketing and support staff, who is working with this item as a user representative, giving the user point of view for the development. And together, the developer, main developer, and this user representative make all the time the minimum viable product specification. So what is the minimum which must be done before publishing into production? And also this user representative does all the testing at the development phase, and he has the final go or no go decision of saying, is this ready for production? And all the developers take part in this code review process. So all the code produced is reviewed together before publishing into production. This is some kind of quality control, and also it gives a good opportunity for developers to learn from each other, because we build our code and then we review it together. So we learn how different developers work and what kind of code they produce. So this is quite good part of the development also. And then the really important part of running all this is working with this Git version or Git code repository. So we, as I mentioned, with this extra server, we have one shared Git repository where all the code and all the most important config files are versioned. So every change we make to the code or into configs is versioned. So we can go back and take a look what it was before. And all our developers have equal access into this repository. So we trust into all our developers that they have access to everywhere in this code repository. And from technical point of view, we have a master branch in Git, which already always is the latest ready code, which is reviewed and waiting to be published. Then we have a production branch, which is the latest in production code, which is actually running at the moment. This branch is needed if, for example, we find out that we have an acute problem in our service. Then we can make the fixes into the production branch and later on merge all these codes together. And then we have pre-production branch, which is a branch for next ready code for publishing into production. This is most of the time this is pointing into the last master, but sometimes not. The master branch can be a little bit further than this pre-production, but pre-production is automated so that when we run these DevOps scripts, it fetches the code from this pre-production branch and pushes it into our production servers. So this branch is part of our automation of getting the code into the service. And also, beside all these official branches in our repository, we have many multiple private for each developer or shared with different developers, different branches for different kind of tests and development code. But every developer can see what others are doing because we publish what we are doing, even though that all those codes never actually finalize in a such shape that they could be in the production, but we save everything. And because you never know when you find out that something which you did 1 year ago, which was at that time, did not finalize. This year, if you remember that, hey, I did this, and you find it out and port it into the latest version and work again, those things can finalize and go into production after all. And because we are using this Git system, we have a full version history from the beginning. So since 2011, all the code changes from the beginning of this new one single Pedanet system is available from our repository. So in the future, some code historian could dig into our repository and find out how Pedanet evolved into what it is nowadays. So using some kind of, it doesn't have to be Git. There are different kinds of code management systems, but some kind of version history is nowadays, I should say, mandatory if you are doing software development. Even if you are a single developer, you get benefits from working with some kind of versioning. And then nothing is ever only good things, and everything doesn't go as you planned. So we have had problems during the years of running and building this Pedanet system. And here I have collected some of those. Of course, hardware failures happen. They don't, using good hardware from good companies, this is not so huge problem nowadays. Nowadays hardware is quite good, but it might happen. And as I mentioned, we try to work against hardware failures by building our system redundant so that we don't have single point of failures, or at least not so many single point of failures. Also, at the software development and also with hardware, there are many cases of broken hardware or broken software, or actually undocumented features. Something works different way than it is documented to be working. So these kind of things are quite difficult to find and difficult to fix when something doesn't work as it is supposed to be. Also, different kind of hacking and this kind of hostile attacks to running systems happens nowadays quite a lot. And actually we have had a couple of cases of denial of service attacks. Not anything huge, but some evil persons have been able to cause us some downtime. But we have reported all those accidents to police, and even found out, they have done their work and found out few of those persons who did denial of service attack against our service, and they have had their sentences from those. But this can happen, and actually denial of service attacks are quite cheap nowadays. So even the students can buy. They don't have to have any hacking skills. They can just borrow daddy's MasterCard and buy a denial of service from network and attack your service. So these are quite possible of running all web services. and other kind of hacking incidents. Earlier days, at the beginning, we had this couple of these cases that because the software we were running on our servers was not upgraded fast enough. There were some vulnerabilities which some hackers were able to use and hack into our system, but nothing big, just small ones. And also different kind of resource bottlenecks in network, in memory, in storage. Anything can happen when you are building a huge system running many users. And these first couple of weeks of this Corona lockdown were quite hectic to us because our usage not only doubled, it actually went 10 times more than normally during the times when schools are operating normally. So we had different kinds of resource bottleneck problems during the first weeks of Corona time. But because we had this information collection, what happens in all pieces of our system, we were able to quite easily find those bottlenecks and fix those by buying more hardware and fixing things. So, but this can be a problem and will be a problem in all systems when the usage goes higher. And one long time problem, because we are building a service for the users, which is mainly used by using only a browser. There is this problem that many users are using quite old and outdated hardware and software on their own machines. For example, really old iPads running old versions of Safari are quite difficult for web system building because they don't get upgrades. They are still in use, but the browser did not get any new features. So, and even some old features might be broken. So the users see the service working badly and think that it is the fault of the service when actually it's their own machine, too old hardware or too old software. And also in schools, even in Finland, schools have really different kind of ways of organizing how they upgrade their computers. So even in schools, there might be really old browsers in use, which is a huge problem for us. Actually, when we published our latest facelift upgrade during the last week, we did quite a huge risk because we decided that we must broke many old browsers. So we have no choice but to stop supporting those old browsers. But that causes some difficult things in schools because now when they go back to school after the summer, it might be that they are using too old browser and now our service is not working for them anymore. So it's always difficult to make that decision what and how old hardware and software you want to support. Okay, so here was the base part of my presentation, and now we have time for questions and comments. I stop this screen sharing now.
Luckily, we have 3 questions in English. You can see them in the question and answering. You can go ahead.
Okay. So the first question is, For how long do you keep the statistics and info for analysis? At the moment, we are keeping the money information for 1 year, not longer. We keep some logs available longer, but those logs are mainly security logs. But this important data is only for 1 year, because our system is all the time moving on. So more older information might be not so important anymore, and it's not comparable. But 1 year is needed because it provides a good basis for the trends of the data, how things are changing and what way they are changing. So 1 year. Second question, do you use insurance at some parts of system development design? Yes, we have done some projects on small pieces of Pedanet development using our university's IT department and their students. And they are mainly really focused, simple parts. And we use that to find new developers, because nowadays finding a good developers for building systems is quite difficult. And working with students, we can pick up good persons from there. And also we have external, it's not interns, but it's professionals, but we are paying for user experience and user interface designers, which are not working directly for the Pedanet, but part-time for the Pedanet. Then the third one, did I miss you mentioning TDD unit testing or similar techniques being used? Yes, I did not mention anything about unit testing, but because we are not doing a complete unit testing on our server, but we have some unit tests for critical parts. And when we have totally automated system, when we publish our code, certain tests are always run so that we can be sure that we don't break things, these big things. But at the moment, it's around something like 30 to 40% of our code that is unit tested. So not everything, but we are using also this automated testing. But we are not using this test-driven development as a working principle. We are quite a small group of developers working quite agile ways. Do you plan showing a warning to end users before disabling support for their web browsers? Yes. At this latest facelift, we decided that we should do this, that we should actually say it out to the users that the reason you are not seeing this service as you should is because you are running too old software. And we are also adding that this might compromise your computer's security, that you are running too old servers. So yes, we are planning, actually, finally, we are planning on showing this kind of information to all these old servers. Then the next question, is Pedanet connected to Wilma? Wilma is Finnish administrative system, which is mainly used in all schools, running all these administrative parts. Pedanet is not directly connected to Wilma, but Wilma can be used as an authentication source. And we are at the moment looking out for different APIs to exchange information with Wilma. Wilma and Pedanet are not competing in the same area. So Wilma and Pedanet actually work quite well together, but at the moment the problem is that Wilma does not provide enough APIs and information, but we and also the Visma software who is doing the Wilma are at the moment finding out the ways how we should tie our services together. And Pedanet has decided that we are not doing any of these school administration things in our software. So we are focusing on learning management system like features, and we are keeping the Wilma as the administrative part of this ecosystem. And at the moment in Finland, this idea of connected ecosystem of different software is actually rising quite fast. We are not there yet. There are no enough APIs, but almost all companies in Finland working in this area are interested in working together and building this ecosystem. Okay. And then there are two things which I don't understand, but I think they are not questions.
Yes, they are not questions.
Yes.
So if there are not any more questions, I guess we can. Jarkko, if you want to add something before we close this webinar, please do.
Yes, thank you. Thank you for your participation in the meeting, and apologies that I was not present in the beginning, but I had some technical problems to log into the system. So, but those technical problems were solved in 15 minutes or so, so I could join the meeting. I would like to thank Juha. Your presentation has been again very good, and there has been a lot of new information. I mean that most of the content from your presentation is very much important and needed from the local point of view when they are now building up the system of their own, because these points are something that you can easily make benefit, and you don't have to make the same mistakes as we had done during the past year. So we can speed up the development in Ukraine. That's super good. And thank you for Vladimir about hosting the event. And thank you for the participants who has been participating in the event, and your questions. Questions are like hitting the bullseye. Very good questions again. And this was the second webinar, and we are going to have another one in the more later in the autumn, somewhere in the August or September. So please stay tuned. You will be delivered this invitation letter later after the vacations. So thank you for everybody. It has been a pleasure to be in this webinar again. And I kindly ask you to give your feedback on the success of this webinar again, because we are going to use this feedback to develop these webinars and to find a better match between what we can offer and what are your needs. So your feedback is very crucial and very important, so that we can design these webinars to match the best with your needs. From my side, thank you for participation and have a good weekend. Now I give some words to Vladimir if you want to say something.
Yes, я хотів просто, thank you, Ярко. Я хотів нагадати, що запис сьогоднішнього вебінару, так само як запис попереднього вебінару, буде надісланий разом з формами, в яких ви зможете надати ваші враження, побажання щодо майбутніх вебінарів. Ще раз дуже дякуємо вам за участь в нашому вебінарі. Сподіваюсь, інформація була корисна і зможе бути використана в нас в Україні. Дякуємо.